Good morning, folks, and welcome back for week 15, our final week of building construction for the fire service. This week you're going to be reading chapter 14 in the IFSTA book, which deals with non-fire collapse. And this is something that fire departments get called to. It's not atypical for a fire department to end up doing a rescue, for instance, at a construction site, or maybe a little less commonly, but where there's been a design failure in the building, and that's led to a collapse. So this chapter is going to give a brief summary of that, and I think probably many of you looked at cases of non-fire building collapse as you did your analysis of the NCST report. Once you've completed the chapter, you'll take the quiz, which is right here on the Blackboard page. And then we have just a few other details to wrap up for the course. One of the things that I'd like you to do, and you can do this before or after you view the quiz, is watch John Norman's Tactics for Fire Officers video on collapse. This is going to be some really nuts and bolts fireground type stuff for dealing with structural collapse. Now I should mention that structural collapse rescue, really technical structural collapse rescue, is a separate technical discipline from basic firefighting. And typically that type of incident is covered or is assisted in by a regional team. So for instance, here in the Madison area, our regional team is the City of Madison Fire Department's Heavy Urban Rescue Team. They would come out, if you weren't working for the City of Madison, they'd come out and assist your fire department in doing that technical rescue. There is some technical training available in this at the REACT Center up at Volk Field, Wisconsin. And actually, I'll see if I can get a link posted here in Blackboard so that you guys can access that. They don't currently have any collapse classes listed, but probably in the coming months they will be listing some of those that are coming up. So if you have an interest in it, that would be a further avenue to pursue. Finally, I want to talk to you about things that we need to get squared away for the end of the course. So the first thing is the NCST research paper, and I know that several of you are still awaiting feedback. I'm working my way, not as quickly as I'd like to, through the things that have been submitted, and I will be giving you feedback on the components of the paper that have been submitted. When you're done with the paper, you need to submit the final draft of the paper here in week 15 in the NCST research paper tab, and you can see that there's this submission, which is a safe assign application here. And that's where you will assemble all of the pieces that you've submitted so far into a single document and submit that for final grading. And again, if you've done kind of the things along the way that the feedback has guided you in, you really should have no issue getting full credit on this final submission because you've already kind of fixed any problems there were with the paper. In light of the fact that you guys are still awaiting feedback on some elements, I'm going to move the due date for this out until the end of next week. So the NCST research paper will be due on or before midnight December 19th, so that's a week from this Friday. So you guys have some time, and again, at this point, really all you're doing is assembling those components which you've already created. So hopefully this won't be too onerous for you. There is the rubric here. If you click on this link, that's going to bring you a PDF, and that is the rubric against which the final document will be graded. But again, it's basically the same rubric against which all of the components were graded. So if you have kind of fixed any mistakes you had along the way, shouldn't be any issue with this. The other thing, and I'll get an announcement out next week for this, but I'll mention it at this point. Next week, you guys will be taking the final exam. And if you look on the left side of Blackboard, you see the last tab that is visible to you as a student is the final exam tab. And when you click on that, you guys right now are not going to see anything because the final exam has not opened. But this icon that says IFSTA final exam will become visible to you as students of the class probably midnight on this coming Sunday. And it'll be available through the end of finals week, which again will be midnight on December 19th. So if you think about next week, kind of what you've got going is you've got the final exam for the course. You're just going to take it on your computer. It's going to be accessible over that time. You can go into the exam. You can leave the exam. The operative thing is that it is submitted by midnight on Friday, December 19th. The final exam questions are drawn from the same pool of questions that were used to generate the quizzes. So if you've been in good shape on the quizzes all along, You should have no issue for the final exam. There are no questions on the final exam that came from outside of the book. Every question asked on the final exam is addressed in the text. So again, if you've been doing the readings, if you've been keeping up with the class, this final exam should really just be a formality for you. The last thing I'd like to look at is I just wanted to talk a little bit more about, or give an example of, non-fire collapse. And so I have a video here that was developed by some forensic engineers looking at the collapse of the Oklahoma City building. It's unfortunate, but the reality is that we frequently don't learn a lot about non-fire structural collapse until we have these tragic events like Oklahoma City. We learned a lot of things there. We learned a lot of things in the World Trade Center, and that's just kind of the nature of the beast, so to speak. So we'll get, let's see if we can get this wave movie to play here. No, I don't want that. There we go. So this is a structural representation of the Oklahoma City Federal Building. And you can see what happened was that the collapse was initiated at the seat of the bomb blast, which was in front of the building and near center span. And I just want to talk a little bit about the mechanism here. So you can see, as it's characterized in this video, the bomb blast took out these three center columns. Now, it was a little bit more complex than that in reality. If you think about the bomb blast, the way a bomb blast damages a building is that it creates a pressure wave, and that pressure wave, exerted over a large surface area, such as the building's walls, generates large forces that's able to break structural connections. In this case, they show the bomb blast essentially disintegrating the columns, but if you read the technical reports on this, it was a little bit more complex than that. The columns are very robust. They're made out of concrete and steel. They have a lot of weight on them. It's unlikely, even a substantial bomb blast is simply going to make them disintegrate. Because they have a small surface area, that bomb blast just doesn't have a lot of area over which to exert that pressure to develop the forces needed to cause the column to fail. So what actually happened in this building was the bomb blast created a pressure wave under this floor slab and lifted the floor slab up. And it had a large surface area, and that the connections between the floor slab and the columns was relatively weak in the upward direction. The floor slab is basically connected to a transverse beam, and most of what held that transverse beam on top of the columns was simply the weight pushing down on the transverse beam. Minimal connections looking at upward forces, because as the structural engineer of this building worked, why would he or she ever anticipate that that building would have a large upward force on it? So that large upward force caused the floor slab to lift. It broke the connection to the columns. The columns then were pushed by the blast wave over, and momentarily the floor slab came back to its original position. But there was so much weight available here, and this span had become so long that there was simply no way that the transverse beam and the floor slab and these adjacent columns could possibly support that weight. And so what you're going to see here is this progressive collapse. It's this idea that we lost these three components initially. The load was repathed. As the load was repathed onto these two columns, they were just simply overwhelmed by the load. So the next two columns that failed did not fail because of the blast wave. They failed because the loads repathed after the blast wave destroyed the original load paths just greatly exceeded their capacity. And you're going to see that here in the video. So you see, okay, this center floor slab, this transverse beam now has failed. The center floor slabs are cracking away. And of course, everything they support is falling right with them. And as they fall, you'll notice now that they start to pull down kind of these vertical components that are now we're attempting to reload path this entire section's load onto this column here and this column here. And they just simply cannot resist that. And so you see what happens is you start to develop these tensile forces here, these moments in these columns causing the columns to roll in towards the center. And a column is not robust to moments, right? A column's good in compression vertically. Columns are not robust to being tipped in. And here you see how they believe that the collapse proceeded. Now, that's a computer simulation. It's not a perfect model. The damage pattern after the collapse doesn't look exactly as that model would have predicted it, but I think it does a good job of illustrating that concept of progressive collapse, that losing a single load path or losing a couple of load paths can cause total building failure if there isn't sufficient redundancy and safety factor in the design of the building. And that's what you saw there. That'll conclude my comments for today. As always, if there's anything I can do to assist you, please feel free to get in touch with me at the contacts listed in the syllabus.